Today we will start learning about Node.js. So now currently version 20 of Node.js is released. So Node.js is an open source and cross-platform JavaScript runtime environment. It is a popular tool for almost any kind of project. It runs on V8 engine, the core of Google Chrome, and it runs in a single process without creating a new thread for every request. Node.js provides a set of asynchronous input-output primitives in its library that prevents JavaScript code from blocking, and generally libraries in Node.js return using non-blocking paradigm, making blocking behavior exception rather than norm. Okay, so to create a Node.js, first you can open your VS Code, and inside that you can create a new file server.js, and after that creating this file inside server.js, one step you have to do, you can download Node.js from their official website nodejs.org. You can download version 20, which is long-term support, but you can also download latest version 21.2, which has latest features, right? So now I have already let me close this. I have already Node installed in my system, so you can check Node-v. I've already installed version 21.1. Okay. So after that, let's write some Node.js code. First, I will import HTTP. Like we will not import, we will use require keywords, and we will first import HTTP, and after that we will import host name. We will call it right. So then we will define the port on which we want to run our server. So I have defined 3000 port. So now we have to create a server with the help of HTTP. We just imported using require. Then we will use its create server method. Inside this we will provide a request and response. This is an arrow function used inside create server. Then we will response dot status code. We will give it a 2000. That's okay, means everything is okay. We get the response. Then we will set header. Its content type and it's simple text plain, and rest.send, we will send the response of hello world, and then we can put a new line after that. So we have created our server code. Now let's start our server.listen. It will listen to port, host name is 127.0.0.1, and after that we will put a callback function. Inside this we will simply console.log that our we will use ternary operator, not ternary operator, conditional server running at http So it's running at host name, and after that the port, right? So that's the whole code for our server. So inside our terminal, to start the server, we will write command node server, simple. So it is saying server running at https 127.0.0.0 and port 3000. If I press control then click on this, it will start a server. Sorry, this is nres.end. Then again we will start our server. If I refresh this, we have this hello world message, right? So our server is started at port 3000, right? So this is a very basic code for Node.js, like how we can create our server. Okay, so the create server method of HTTP creates a new HTTP server and returns it. Server is set to listen on specified port and host name. When the server is ready, callback function is called. Okay, the case is that server is running. Okay, so whenever new request is received, the request event is called, providing two objects, and request and response. Okay, there are two objects are essential to handle HTTP call. The first provides request details. In this simple example, this is not used. We have not used request, but we have used response. Okay, so we have set the response code to 200, and it means to indicate a successful response. We then set the content type header, so that is content type. We have set the header, it is text plain because we have used simple hello world. It's a simple text, right? So after that we close the response, adding the content as an argument to end. So here how we will end the response. So this is how we can install Node.js. So we can download it from this website. This is very simple. What's next? How much JavaScript do you need to use Node.js? This is a recommended learnings before diving deep into Node.js, like lexical structure, expressions, data types, functions, distributed arrow functions, loops, scopes, arrays, template literals, strict mode, ESMA 2015, ESX6 and beyond. Asynchronous programming. Okay, the following concepts are also key to understand asynchronous programming, which is one of the fundamental parts of Node.js. Okay, so these are the things that we have to learn about: timers, promises. So this is how you can learn about these functions, promises, right? So now they're saying differences between Node.js and browser. With the both browser and Node.js use JavaScript as their programming language. Building apps that run in browser is a completely different thing than building Node.js application. Despite the fact it's always JavaScript, there are some key differences that make your experience radically different. From a front-end developer who uses JavaScript, Node.js app brings them a huge advantage. Comfort to programming everything, the front end and back end in a single language. You have a huge opportunity because we know it's hard to fully deeply learn a programming language. By using the same language to perform all your work on web, both on client and server, you are in a unique position of advantage. In the browser, most of the time you're doing is interacting with the DOM or other web API platform like cookies. These do not exist in Node.js, of course. You don't have the document and window, and all the objects are provided in browser. In browser, we do not have all the nice APIs that Node.js provides through its modules like file system access functionality. Another big difference in Node.js, you can control the environment unless you are building open source application that can anyone deploy anywhere. You know which version of Node you will learn the application on compared to browser environment. We do not need the luxury to choose what browser your visitor will use. This is very convenient. You can write all the modern JavaScript. This JavaScript moves slow, but browser can be slow to upgrade. Sometimes on the web you are stuck with using older JavaScript. You can use Babel yes, but Node.js you do not need that. And the difference is Node.js supports both CommonJS and ESS module. While in the browser we're starting to see 6 modules standard being implemented. In practice, this means that you can use both require and import in Node.js while you're limited to import in browser. They have told about our V8 engine. So this is very important in the Node. Node.js is based on V8 engine that powers Google Chrome. It's a thing that takes out JavaScript, executes it while browsing with Chrome. V8 is JavaScript engine. It parses and executes JavaScript code. The domain other web platforms are provided by browser. The cool thing is JavaScript engine is independent of the browser in which it's hosted. The key feature enabled the rise of Node.js. V8 was chosen to be the engine that powered Node.js back in 2009, and as the popularity of Node.js exploded, V8 became the engine that now powers an incredible amount of server-side code written in JavaScript. Node.js ecosystem is huge, and thanks to V8, which also powers desktop apps with projects like Electron. There are other JS engines, cost for performance. V8 is written in C++, and it's continuously improved. It's portable and runs on Mac, Windows, Linux, and several other systems. V8 is evolving like any other JavaScript engine to speed up the web and Node.js ecosystem. On the web, there is a race of performance that's been going for and we as users and developers benefit a lot from this competition because we get faster and more optimized machines year after year. Modern JavaScript engines no longer interpret, they compile it. The JavaScript is internally compiled by V8 just-in-time compilation to speed up the execution. This might seem counterintuitive, but since the introduction of Google Maps in 2004, JavaScript has evolved from a language that was generally executing a few dozen of lines of code to complete applications with thousands to hundreds of thousands of lines running in the browser. Our application can run for hours inside a browser rather than being just a few form validation rules or simple scripts. This is npm packages. We have already know what are the npm packages, so I will not go into this. There is ECMA 2015, the features which are in the progress, like Node.js, the difference between development and production. You can have different configurations for production and development environments. Node.js assumes it's always running in a development environment. You can signal Node.js that you're running in production by setting this is done by executing the command export node env is equal to production in the shell. For example, Pug the template user compiles in debug mode. Okay. So later we will also learn about express.js, Node.js TypeScript. I will not go into this TypeScript because it will make our code a little bit complicated. So Node.js with WebAssembly. Okay, WebAssembly is a high-performance assembly-like language that can be compiled from various languages, including C++, Rust. Currently, it is supported by Chrome, Firefox, and other browsers. A binary format called WebAssembly module with a WASP extension. Okay, it runs with this extension. Key concepts module, a compiled WebAssembly binary. Okay, a WASP file, memory, resizable array buffer, resizable typed array of references not stored in memory. Okay, in order to use WebAssembly, you need a WASP binary file and set of APIs to communicate with WebAssembly. Node.js provides the necessary APIs via Can directly access OS functionally on its own. Third party to last time can access this functionally. Last time we utilize EVSIM to access operating system functionality. Okay. Asynchronous flow control. At its core, JavaScript is designed to be non-blocking on the main thread. This is where the views are rendered. You can imagine the importance of this in this browser. When the main thread becomes blocked, it results in infamous freezing. This creates some unique constraints that only function style programming can cure. This is where callbacks come in picture. However, callbacks can become challenging to handle in more complicated procedures. This often results in callback hell, where multiple nested functions with callback make code more challenging to read, debug, and organize. So like this, we have output inside result 4, then inside result 3, then result 2. Of course, in real life, there would most likely be additional lines of code to handle result 1, result 2. Thus, the length of and the complexity of this issue usually results in code that looks much more messy than example above. This is where the functions come into great use. More complex operations are made up of many functions. The initiator style import is the first function in the sequence. This function will accept the original input, if any, for the operation. This operation is an executable series of functions, and original input will primarily be variables in a global environment. Direct invocation with or without arguments, valuable values obtained by file system or network requests. Okay. Immediate function will return another function. Okay, and the terminate function will invoke callback. The following illustrates the flow to network or file system request. Here the latency is 0 because all these values are available in memory. Okay. First initiate. Now this is a function middleware some input function result. Let's try to run this code inside this. Just open our terminal. Node server. Okay, middleware. This is a middleware function. Some input callback. Okay. Let's clear this. I will install a package npmi nodemon, so I do not have to run again and again node server. Okay, nodemon server. Have we installed nodemon? Okay, pass algorithms. You don't only pass your app, your node app. Okay, let me try nodemon server.js. Okay, nodemon is not. Wait a minute. Let me install it globally. Okay, we have inside our package.json node mon. Let me clear it. Node mon. Let's try again in another. Okay. Right. npm start node mon. Now we have in our local development, we have started it, right? So let's try to console log here if it's working. Hello world. Okay, let me put this code the top. So if I change this to 4000, so okay, now it run. Server is running at test. Okay, everything is now working. So let me hello, this function touched by middleware. So they have given an example of middleware, like wait a minute. First we will initiate. First we have called initiate. It has some input. Hello, this is a function, and then there is a middleware. It is accepting some input and callback. Okay, and it is turning final function. All right. So touched by middleware. This function touched by middleware and terminate over executing callback. All right. So this is an example of some middleware in our function. Middleware some input, right? Middleware some input and callback function. This callback function is provided inside this final callback, and it's callback terminated by executing callback. So this is example of some middleware working. Immediate function will return another function, and a terminate function will invoke the callback. The following flow illustrates the flow to network or file system requests. Okay, then the state management. State management functions may or may not be state dependent. State dependency arises when the input or the variables of function relies on outside function. In this way, two primary strategies for state management: passing new variables directly to a function, acquiring a variable value from cache session or database network. Not I didn't mention global variable. Managing state with global variables is often a sloppy. Okay, control flow. If an object is available in memory, iteration is possible and there will not be a change to control flow. Like take the example of this, just study this example. Remove this. So sing song, this will work. Function get song. Okay, song is get song. They have iterated the song bears on the wall. Okay, this is sing song. Okay, sing song, song get song, then get song, return song. This inside our song variable we are iterating songs and just putting it here. If not, song throw error. Okay, then if there is a song, then console log it. Okay. However, if data exists outside of memory, the iteration will no longer work. Okay, why did this happen? Setup and instruct the CPU to store the instruction elsewhere on the bus and instructs that data is scheduled for pickup at a later time. Okay, thousands of CPU cycles pass before the function hits again at the 0 millisecond mark. The CPU fetches the instructions from bus and executes them. The only problem is that song was returned thousands of cycles prior. Okay. The same situation arises in dealing with file systems and network requests. The main thread simply cannot be blocked for an intermediate period of time. Okay, therefore we use callbacks to schedule the execution of code in time in a controlled manner. You'll be able to perform almost all of your operations with the following three patterns in series. This is some really advanced stuff. Seal procedure operation.shift. Execute a function with arguments. Operation callback executes function. Okay. Arguments function operation. What? Execute function operation. Operation.shift. Full parallel. When ordering is not an issue, such as emailing a list of 1 million email recipients. So count 0, success 0, failed. Recipients Bart, March, Omar, Lisa, Maggie, and dispatch. There is a dispatch function. It is receiving recipient and callback. Send email. Okay. Let's also try this code if we can get what they are trying to say. So recipients, okay. Then there is a dispatch. Just let's see what is happening. For our recipients, for each function, dispatch recipient. Note error, success is okay. If count is equals to recipient dot length final. This is just like hypothetical code. They are just added to show what's happening. It will, I think, not run inside this, right? It's a hypothetical SMTP client. Okay, it will just give this example is just to give just show us how it can happen. It will not run. A limited parallel with limits such as successfully emailing 1 million recipients from a list of, okay, how many? So many users. Each has its own use cases, benefits, issues you can experiment and read about in more detail. Most importantly, remember to modularize your operations and use callbacks. If you feel any doubt, treat anything as it were middleware. Okay. So overview of blocking and non-blocking. Okay, this comes the blocking non-blocking calls to Node.js. This will refer to event loop and libov, but no prior knowledge of those topics is required. It is, input out refers to primarily to interaction with the system's disk and network. Supported by libov. Blocking is when the execution of additional JavaScript in Node.js process must wait until a non-JavaScript operation completes. Okay, this happens because event loop is unable to continue running JavaScript while a blocking operation is occurring. In Node.js, JavaScript that exhibits poor performance due to being CPU intensive rather than waiting on a long JavaScript operation such as input output is not typically referred as blocking. Okay, blocking is only referred to as when there is some non-JavaScript operation running and it blocks our JavaScript code. So that's what we call blocking. Synchronous methods in Node.js standard library that use libov are most commonly used blocking operations. Native modules may also have blocking methods. All of the input output methods in Node.js standard library provides asynchronous versions, okay, which has non-blocking and accept callback functions. Some methods have blocking counterparts which have names that end with sync, right? Okay, now we will compare the blocking and non-blocking code. Blocks here until the file is read. We will use some file system module fs, and this is a asynchronous read. This is a read file sync. If there is a sync in any of your Node.js method, that means it's blocking, right? That means it's synchronous. And if there is nothing sync with its name, then it's asynchronous by default. That's good. The first example appears simpler than the second, but has a disadvantage of the second line blocking the execution of any additional JavaScript until the file entered is read. Note that the synchronous version, if an error is thrown, it will need to be caught or the process will crash. In the asynchronous version, if it is up to the author to decide when an error should throw as shown. Okay. Let's create a simple file here. Inside this file.md, just write this is md file. Okay, so we'll remove this, our hypothetical code. Okay, so now we will import our fs module. Const fs is equal to require fs. So here we will write first we will write the synchronous code, or I can say blocking code. Here data is equal to fs dot read file sync. We will read from our current file. Okay, let's console it. Just write some JavaScript like const number is equal to 10, then console.log number, right? So let's again, why nodemon is not working properly. if I write this code here, I think let me write it here. Just remove it, again run it. Okay, now our code is running. We do not have to run it inside this server. Okay. Actually, okay. Just zoom it a little bit. We can remove our server for now. Okay, just comment out this code. Okay, now we will work with this thing. Should I create a JSON file? I mean, JSON file. Message. This is JSON file. Now if I go to server and then again run JSON, again this code data dot message undefined. If I write okay. Okay, let's assume this is a buffer. This is the file it's reading, and this is the number. We have a console log, right? So so this is a synchronous code, but not in equivalent asynchronous code. Okay, asynchronous. Now we will run our asynchronous code. Non-blocking, or I can say non-blocking code. What I will do is fs dot read file from same file dot json. Now there is a callback in our asynchronous error and data. If there is error, throw error, right? And then console log data. So after that we will just write a JavaScript code and console it. Let's write it number 1. Okay. So let's comment this out. Okay, so here in this case our JavaScript out of this code ran first, executed first, then the code inside this executed second. Okay. So that means so there is no blocking. So that means this code is not blocking this code. It is running as it's on, and when this code ran, it is consoled. So but here, if I comment out this and uncomment this, so that means it is blocking this JavaScript code. So if I run again, so now buffer is executed like console first. The buffer comes from this read file sync. It's blocking this code, so that's why this code ran second. So that's how the non-blocking or async code run. It is non-blocking because JavaScript execution can continue and more work will be called first. The ability to run more work without waiting for a file to read to complete is a key design choice that allows for higher throughput. So that is the main feature of Node.js. Non-blocking code will run. So that's why Node.js is so performant. I will be so concurrency and throughput. I will come back later in a bit. Okay. Hmm. So concurrency and throughput, JavaScript execution in Node.js single-threaded. Okay, so concurrency refers to the event loop's capacity to execute JavaScript callback functions after completing other work. Any code that is executed on any concurrent manner must allow event loop to continue running as a non-JavaScript operations like input-output are occurring. As an example, let us consider a case where each request to a web server takes 50 milliseconds to complete, and 45 milliseconds of that 50 milliseconds is database input-output that can be done asynchronously. Choosing non-blocking asynchronous operation that frees up that 50 millisecond per request to handle the request. Okay, this is significant difference in capacity just by choosing to use non-blocking methods instead of blocking methods. Okay, so the event loop is different than models in many other languages where additional threads may be created to handle concurrent work. So you can read this. Additional resources, what's above. Above is a multi-platform support library with focus on asynchronous input output. Show me code. Okay, starts above. Cross-platform asynchronous input output. Okay. So now next is JavaScript, asynchronous programming and callbacks. Okay, now we'll learn about asynchronous programming and callbacks. Okay. So computers are asynchronous by design. Okay, asynchronous means that things can happen independently of main program flow. Okay, so that they do not depend on each other to run. Current consumer computer side program on a specific time slot and then stops its execution, let other program continue execution. This thing runs in a cycle so fast that it's impossible to notice. We think our computers run many programs simultaneously, but this is an illusion, except on multiprocessor machines. Okay, programs internally use interrupts, signal that emitted processor to gain attention of system. Let's now not go into internals of this now, but just keep in mind that it's normal for programs to be asynchronous and halt their execution until they need attention. Okay, allowing computer to execute other things in meantime. When a program is waiting for a response from network, it cannot halt the processor until the request finishes. Normally, programming languages are synchronous and some provide a way to manage asynchronicity in the language through libraries. Like C, Java, C#, PHP, Go, Ruby, Swift, Python are all synchronous by default. Okay. Some of them handle async operation by using threads, spawning a new process. So what about JavaScript? JavaScript is synchronous by default. Okay. Like all other languages, and is single threaded. This means that code cannot create new threads and run in parallel. Okay, lines of code are executed in series one after another. For example, A is equals to B, B is equals to A is equals to 1, B is equals to 2, and then C console log do something. Okay, but JavaScript was born inside the browser. Its main job in the beginning was to respond to user actions, like on click, on change, on submit. So how could it do with this synchronous programming model? The answer is in its environment. The browser provides a way to do it by providing a set of pages that can handle this kind of functionality. More recently, Node introduced a non-blocking input-output environment to extend this concept to file access, network calls, and so on. So let's learn about callbacks. You cannot know when a user is going to click a button. Yes, you define an event handle for click event. This event handle accepts function which will be called when an event is triggered, like document.get element by button. Button has an add event listener. Then on the click, this function will be executed. This is so-called callback. A callback is a simple function that's passed as a value to another function and will only be executed when the event happens. We can do this because JavaScript has a first class functions. Okay, this is passed as a value to another function, like here. This is the callback function passed inside this add event listener. This is just like another value, just pass as an argument. We can do this because JavaScript has first class function which can be assigned to variables. Okay, it is a first class means they can be assigned to variables, okay, and passed around other functions called higher order function. This is like functions passed inside the function. It's a common to wrap all your client code in a load event listener in the window object, which runs the callback function only when the page is ready. Okay. Callbacks are used everywhere, not just in DOM elements. Okay, one example is using timers. So this is a callback function they have used inside this set timeout. This is the first argument callback, and this is a second. This is a seconds. This is set timeout. XHR request also accept a callback. Okay, in this example, we're sending function to a property that will be called when a particular event occurs. In this case, the state of request changes. XHR new XML request dot on ready state change. If it is ready, state is 4. Status okay. How do you handle errors with callbacks? One very common strategy is to use with what Node.js adopted. The first parameter of any callback function is the error. Okay, and then if there is no error, the object is null. If there is an error, it contains some description of error and other information. So for example, here is a read file, right? So inside this code, I will just move this code like here. There is a callback function inside it. There is first argument is always error, okay, and second is data, right? So this is the read file function. So if there is an error, it will throw. If there is no error, it will read this file.json, and this will be inside this data. You can console it or whatever you want to do. Okay, if error, then console log error and process data. Okay, let's not throw the error, just console it. Let's change something to MD. We don't have a MD file, we have a JSON file, so it will throw an error. Just okay, so it has thrown an error like no such file or directory, file.md. So that's how the error handling works in callbacks. The problem with callbacks, okay, callbacks are great for simple cases. However, every callback adds a level of nesting, and when you have lots of callbacks, the code starts to complicate it very quickly. Like here, add listener, load, then document button, add listener. This is a callback. Then inside this callback, there is a set timeout. It has another callback. So this is called callback hell. The callback inside callback inside callback. This is just a simple levels for code. We have seen so much more levels of nesting, and it's not fun. Yes. So how do we solve this? Alternatives to callbacks. So starting with ES6, JavaScript introduced several features that help us with asynchronous code that do not need involve using callbacks. So that's how comes promises and async await in ES6. JavaScript timers. Hey everyone. Okay. Hello Vicky Rawat. Hello Ramesh Kumar Jha. Hello Gautam Patel. Hello everyone. So discover JavaScript timers. Okay, there are some JavaScript timers. So there's lots of things that we can read from docs actually. Okay, so this is the timeout. Zero delay, code will be prints at interval. So set timeout is a function to execute something after a particular time. So for example, remove this code. And suppose we have like constant number let's say it returns 10. Okay, so we have like set in timeout function, set timeout, it will receive a callback function first, like we will call num here, and we want to execute after 2000 milliseconds, that is 2 seconds. Okay, so if I run this, let's console log it, console log 10. Okay, now let's run our server. It will wait for 2 seconds. Now it has given us output of 10. Again run. It has waited for 2 seconds, right? So that's how set timeout will execute. So there is also option to clear timeout. Okay. So to clear timeout, you have to put set timeout function inside something like variable ID. So now if I run node server, there is nothing delay. It's not even running because it has already cleared it. So that's how you clear the timeout. Zero delay if you specify time to zero callback execute as soon as possible, but after the current function execution. Okay. So even if it has zero delay, the code outside will run, and the code inside this set timeout will run after, even if it's written before this. So before and after. Okay, this is consoled before, this is consoled after, right? So this is a timeout set interval. It's like set interval is do something after every 2 seconds, right? Like suppose example, let's take our example, previous example, just clear timeouts, set interval, and we want to run this num function after 2 seconds, every 2 seconds. So now it's set interval, it's running every 2 seconds. This num function is executing after every 2 seconds. So this is actually arrow function, and this is console log. Okay, so now there is option to clear interval, like clear timeout. We have clear interval because we do not want to just keep it like running forever. I think it has stopped now, right? So that is set timeout and set interval. So there is so much in Node.js that we still need to cover. Like inside, if you go to Node.js documentation, we are currently covering documentation. There is a learn and there is a docs, and if I go to its API, so there's so many things: buffers, C++ add-ons, child processes, cluster, console, core. There's so many console types we can do. Okay, callback, debugger, deprecated APIs, diagnose channel, domain. Okay, it's deprecated. HTTP 2. So it has explored different like server side example. uh, hmm so we are currently doing this thing. hmm. Hmm. So what is next tick? As you try to understand Node.js event loop, one important part of it is process.next tick. Every time the event loop takes a full trip, we call it a tick. When we pass a function to process.tick, we instruct the engine to invoke this function at the end of current operation before the next event loop tick starts. Okay. The event loop is busy processing the current function code. Okay, when this operation ends, the JS run engine runs all the functions passed to next tick calls during that operation. It's a way we can tell a JS engine to process a function asynchronously after the current function, but as soon as possible, not queue it. Much later when using. So here is the example. First is number 1, set immediate, and then before the timeout. Number 3, timeout running last. Okay, so this is some like order in which they will run. Simple JavaScript will run first, then next tick will run the second place, then set immediate on number 3, set timeout on the last. So this will be the output. So understand next set immediate when you want to execute some piece of code in asynchronously, but as soon as possible. One option is to use set immediate. You want to execute some piece of code asynchronously, but as soon as possible. Okay. Any function passed as set immediate argument is a callback that's executed in next iteration of event loop. How is set immediate different from set timeout? Passing is 0 millisecond timeout and from process to next tick and promise.then. Function pass to process.next tick is going to be executed on current iteration of event loop after the current operation ends. Okay, this means it will always execute before set timeout and set immediate. Okay, set timeout callback with 0 millisecond delay is very similar to set immediate. The execution order will depend on various factors, but they will be both run in the next iteration of event loop. Okay, process.next callback is added to process.next queue. A promise then callback is added to promise microtask queue. So we have these console logs, these functions. First we will start, then set immediate, new promise, resolve part, then resolve console log, resolve process dot next tick. Oh my god. This code will first call start, okay, then call for. Where is the for? Okay. just okay. So first start is this code is executed, then for that means process on next tick for then bar it is inside then resolve promise dot then and zoo. What is a zoo? Where is a zoo? It's in the process on next tick. Okay, so last is bars. It is in the set immediate. So even it's at the second place, it is executed last. So that is some really going deep inside Node.js. Node.js event emitter. If you work with JavaScript in browser, you know how much of interaction of the user is handling through events like mouse clicks, keyboard button pressing, reacting to mouse movements. On the backend side, Node.js offers the option to build a similar system using events.module. Okay, in this particular for the event emitter class, usually used to handle our events. Okay, you can initialize using where. Okay, we can import it from events. So event meter is equals to event meter, let's call it meter, is equals to new event meter. This object exposes, among many others, the on and emit method. Okay, emit is used to trigger an event. On is used to add a callback function that's going to be executed when the event is triggered. Okay. So this is how event emitter, EV emitter dot on. First argument we will provide a start. We'll give a keyword, and then we will provide a callback function console.log. Then we will write something like started. Okay, so to run we will write emitter dot emit. We want to emit start because we have a, what we can say, some event on in the on method. So if we run it, it says started, right? So again, if we create another emitter with the on, let's say finished, let's say finished, Now if we emit again, ev dot emitter dot emit finish, now it will be finished, started and finished. Okay, so that's how the events happen in Node.js. Okay, you can provide multiple arguments inside emitter, like here. Okay, like here start, I can put a started at started at start. If I then I have to provide some value, then if I write node server started at 10, because we have provided 10 in the emit. Okay, so that's how the event handlers work. So now let's go to Node's file system. Okay, BD normal sync, can you make a simple backend? Okay, we will make a backend, but currently we are reading the documentations, like we are learning about ins and outs of Node.js. Right, so now we will learn about file system. Okay, so we will first const fs is equals to require fs. So after that, let's create a text file. Just remove this, I think. Let's create a text file, file.txt. Okay, this is text file. So after that, fs dot, we can use stat method, and after that we can access file.txt, right? Then error stats. Then if error, console dot error error. So after that, if error, it will throw an error. If there is no error, just check if by just changing its extension. I will start the server again. We have a error, right? Wait, this was the error. This is not the error. just clear it, and again node server, no such file or directory, file.json. So it has thrown an error. Now just put the correct extension. With the stats we can check, is it file, put it in console.log to check if it is a file. Yes, it's a file. We can check like, is it directory or is it symbolic link, or its size, or even its size. Stats dot size. So its size is 17. 17 bytes, I think, right? Yes, it's in the bytes. So also we can read the file, fs.read file. So this is very common. File.txt error data then if error, then throw error. Otherwise we want to console.log our content of our file, so that comes in data. Let's see again. Okay, it comes in buffer always. Reading file. Okay, to read the file we have to provide a UTF-8. So currently it is showing as a buffer. So to show the file UTF-8, now again I will run node server. This is text file, so we can now access its content. This is text file. Great. We can also write files inside something, like if you want to write something inside a file, fs.write file, this is async, we want to write inside file.txt, and then the content, this is the content, and if there is error, okay, we will use a very simple arrow function. If error, console.error, then error. Alright, so if I run this command, there should be some content change inside this. Hey, how are you? Okay, this is changed now. Now I can say, what are you doing? So again, if I run node server, the content of this file will change. What are you doing? Right? So that's how writing will work. The usual way of to run a Node.js program is to run globally available node command. Once you install Node.js, pass the name of file you want to execute. If your main Node.js application file is app.js, you can call it by typing node app.js. Suppose, for example, this is server.js, we rename it to app.js. Now, with node server, it will not run. It will run with node app. Okay, right. Node command has to be re-executed in a batch whenever there is a change in application. Yes, that's a problem. To restart application automatically, use the node1 module. Install node1 global system path. You can install node1 as a development dependency. This local installation can be run by calling it from within the npm script such as npm start or using npx nodemon. npm I saved have. We will edit a development dependency. Just run nodemon app.js. There is some problem. It will not run. You can write a scripts, I think, like start script, and you can run npm start nodemon. And app.js, and now we will write npm start. Okay, do not want that. Let me start. What's happening? So if I start here, like npm start nodemon, just npm start nodemon, just remove it for now. Npm start nodemon. So local installation nodemon will not available in your system, otherwise you cannot use it directly from command line. Instead, local installation node can run by calling it from within scripts such as npm start or with npx nodemon. Huh. Okay. Okay. So let's not go into the Node 1 thing. Let's cover the Node.js. So this was all about our Node.js learn. So after that, there are dogs. There are version 20 APIs. Like first is assertion testing. Hmm. Okay. Async hooks. What is it? Async sources present object with an assert call. This call may be called multiple times, such as connection went create server. What is a buffer? When converting between buffer and strings, character encoding may be specified. If no character encoding is specified, UTF-8 will be used as default. Buffer from hello world. Okay. So that's how you can work with buffers. You can convert into ESM, I think. So that is another thing. You can use like wait a minute, like const buffer from no buffer is equals to require node buffer. So alternatively, we can, this is a common JS, so alternatively you can use ESM, so we can actually import it directly. Import buffer will remove the require from node buffer. So that's how you can, now in Node.js you can use ESM imports. So let's get a buffer from hello world. We'll convert it to UTF, right? Then console.log, then buffer dot toString. Node, let's clear it. Node server, node app. Wait a minute, we have to write type module inside our package.json. then it will happen. UTF-8, let's clear it. Now it worked. So I think you have to use inside your package.json type module, then you can use import. So then you can use ESM modules. So that was about buffer. So there are so many other things in the Node.js. We have covered the events and what we can do next? Child processes. If you want to use ESM modules like import export, you have to write the extension .mgs for your file, then it will work. Or you can inside your package.json file write a type field with the module. Pipeline. Now we are studying about the stream. Let's run our app again. File.txt pipeline succeeded. Create read stream, create gzip, create write stream. Create another file, file1.txt. Okay, let's do it again. We have a new file creator.txt. Okay, so this is the pipeline. Hmm. So I think now I should study about express.js, which is a framework for Next.js. So in this framework, it has covered so many things about Node.js, so we don't have to go through all the documentation to get the most out of Node.js. So express.js is a framework for Node.js. It's fast, unopinionated, minimalist web framework for Node.js. Right? So npm install express, save. We will install the express and save as our dependency. Okay, we have installed express. Okay, so now assuming you have already installed Node.js, create a directory to hold your application, make that you're working directly. Okay, so let's make a directory like my app. So we will open inside this app, open folder, technologies, Node.js, my app, open it. Currently there is nothing. So first we will write npm init to initialize the npm. Package name, my app, version 1, description, express app, entry point, dex.js, test command, nothing, keywords, nothing. Okay, so it has created our package.json file. Entry point is index.js. Now we will create a very basic hello world example. Inside this, close this, we will create a our entry point is index.js. We can write it index.js, or if I want it to be app.js, I can write app.js. Inside package, I will write app. That's our main file. Close it. Then okay, write express require express. We will first import our express library, and then we can write a app is equals to express. We will call a function of express. Then we will define import in a variable. I can define it 3000 or anything you want. Then so what express does is it just simplifies all the things of Node.js, so we don't have to go through all that very deep documentation that we were reading previously in this live stream. So app.get on the main path, on the root path, we can write request and response stat send hello world. That is the main thing we do when we learn anything initially. So then after that, app.listen. Okay, then port, then console.log app listening to or listening on port to run it. We can write clear it node app.js. So it's saying, okay, why I have put another, it is saying app is listening on port 3000. Okay, so now we will use a package named express generator. So we can use you can run the application generator with the command npx express generator. So it will ask you to add this package. Continue, yes. Okay, so what express generator has done is it has created some files and folder for us, like it has made a some skeleton, project skeleton for us to continue, right? So inside our app.js, it has written all this code for us: HTTP errors, express, path, cookie parser, Morgan, like routes. It has even created our routes, right? Like index router, index router. Okay, again. User router. respond with resource does not send. Okay, so we can learn so much from this images, JavaScript style sheets. We have to install our dependencies that it has express.js has added. Now it has installed the packages. Now we will write a command inside our terminal, debug my app colon star npm start. So it has started a app on local server. We can access it on localhost 3000. Let me just remove it, localhost 3000. Okay, so we have express. Welcome to express. This was created with the express generator, right? Get 200. Okay, so what they're doing, let's see what they're doing. On the root path they are rendering this thing, res.render index title express. This is the home page. Now if we go to users, wait a minute, this is the users. Let's see users. Let's go to users path, respond with a source, because inside our users outer we have sent a response, respond with a source. Okay, so next is basic routing. So we're almost into the 2 hours live stream. Okay. So let's cover the basic routing. Routing refers to determining how an application responds to a client request to a particular endpoint, which is a URI path or a specific HTTP request method. Okay, each route can have one or more handler functions which are executed when the route is matched. So they have the following structure, like app dot, then there is a method. It can be like any method, like get, post, put or delete method. So after that there is a path on which we want to run this method. After that, there is a handler, and like what exactly we want to do on this path with this method. So this is what the routing is. So we will do some example. On the home page we have let's just comment this out. Let's write app dot okay, not app, router. We can write router dot get on the root path, then again request response rest dot send. It will send the response hello world. So inside this our root path, wait a minute, we have changed something in our code, so that's why. If I refresh this, no, if I close this and again run our app, users cat will start again our app. Let's see what happens. Now we are seeing hello world. Okay, now also except this get request, we can use post inside the same path. Then we can write go to post request, then again what it is saying. So also we can use put here, and there is another command delete. Okay, so that I can do when a full example can be shown when we have a database, right? So we have some APIs, so that's how we can do it. So I think now I should close the stream, and then I will come back later in the next stream. Thank you all for watching.